Welcome. We're talking simplifying fractions, our second week of fractions. Go ahead and attempt the problem of the day. Feel free to pause the lesson and come back when you're ready. Here we go. Alright, simplifying fractions. When you cannot divide any other number other than 1, because you can divide anything by 1 all day, every day, for the rest of your life. When you cannot divide any other number other than 1, the fraction is in simplest form. So for example, let's look at a couple of these fractions down at the bottom. 9 and 10, there's not a number other than 1 that can be divided out. 8 and 10, I can divide 2 out of both of those, so not simplest form. 3 and 4 is in simplest form because I can only divide 1 out. 9 and 18, I can divide 9 out of each of those. In class, we did a little activity where we compared your two crushes. Things that you liked about crush 1, things that you liked about crush 2. The things that you have in common, or that they both have in common, we refer to as the greatest common factor. So it's the greatest thing, the greatest piece of the puzzle, when we're talking about people, that you have in common. With numbers, it's a little bit easier. We're looking at just factors. Factors are numbers that can be divided out of another number evenly, or it's the numbers that make up another number. So, for example, the factors of 6 are 2 and 3. Those are two factors that multiply to make 6. If we looked at 6, for example, like I just said, we have 1 that I can divide out. We have 2 that we can divide out. 3 and 6. 6 divided by 1 is 6. 6 divided by 2 is 3. 6 divided by 3 is 2. And 6 divided by 6 is 1. They're all factors. When you are finding or simplifying fractions, you need to find all of the factors of both your numerator and denominator, and then find the biggest factor in both lists, or greatest. So that's why it's very important, and I'll show you how to do this, very important to have these factors in numerical order. Now you could sit here and try to figure out the factors, just kind of list them out. Let's see, 20, well I know that 1 goes into 20, 2 goes in, let's see, 5 goes in, 10, oh I forgot about 4, and then the 20s. It's very challenging to get them in order on the first try. That's why we have what I lovingly call the mountain method. So we have our little mountain climber here to help us out. The mountain method allows you to find the factors in order. Always start with 1 and the numbers. So I'll do the numerator first, 20. And then we start climbing the mountain. Go up the left side of the mountain in order, 1, 2, 3, 4, etc. 2, well, does 2 go in? We look at our divisibility rules. Is the last digit even? Well, 0 is technically an even number, so yes. Ask yourself, 2 times what makes 20? Or you can do 20 divided by 2 to find 10. So numbers on opposite sides of the mountain multiply together to make that number. 3, let's go up. Go into our divisibility rules. The sum of the digits is divisible by 3. 2 plus 0 is 2. Well, I can't divide 2 by 3, so it's done. 4. Does 4 go up? 1, 2, 3, 4 will be the next number. If it is even and the quotient you receive from dividing by 2 is even, I divided by 2. The quotient is 10, which is even, so that means 4 works. 4 times 5 is 20. The next number we did 1, 2, 3 did not work. 4 worked. 5 would be the next number. When the next number you want to check is on the other side of the mountain, you are finished. Let's do 35 next. Always start with 1 and 35. 1 in the number. It's not even, so 2 doesn't work. 3 plus 5 is 8. Can't divide that by 3, so 3 is out. Well, it's not even, so 4 can't work. Does not end in 0 or 5, so 5 does not work. 2 and 3 are not on the list, So, oh, sorry. Let me take a step back. 5. It does end with 5. I'm sorry, ladies and gentlemen. So 5 times 7 makes 35. 6 would be next. Well, 2 and 3 are not on the list. And 7 is next, but it's on the other side of the mountain. Then we go through and look at all of these numbers, all of these factors in order. Start at the right side of the mountain and find the biggest number they have in common. 35, 20, 7, 10. 5 is the biggest number in both lists. The last step in simplifying with your GCF is to divide by your GCF. Now you've already done this. You don't have to think about the division if you found the factors this way, because 20 divided by 5 is 4. 35 divided by 5 is 7, because numbers on opposite sides of the mountain multiply together to make that number. So our answer should be 4/7. Down here, as we were using them during the process of finding the GCF, are our divisibility rules. Those come very much in handy when finding all of our factors in order. All right, let's try one together. Let's try actually two together. So we would start with 12 and 30. 1, 12. It's even, so 2 goes in. 2 times 6 is 12. 1 plus 2 is 3. Well, 3 is divisible by 3, so I can put that there. 3 times 4 is 12. The next number I would have checked is on the other side of the mountain already. Start with 1 and 30. It's even, so 2. 2 times 15 is 30. 3 plus 0 is 3. I can divide that by 3, so 3 goes on. 3 times 10. Remember, the rule for 4 is if I divide by 2 and the number across from it's even. 15 is not even, so 4 does not work. If it ends in a 5 or 0, 5 works. So I put 5. 5 times 6 is 30. The next number I check is 6. It's on the other side of the mountain, so I am done. So now I'm going to go through and find the biggest number they have in common. 30, 15, okay, I see 12 on the other one. 10 over 6 is the first number that both of them have in common, going right to left. So I divide top by 6. I divide bottom by 6. I get 2/5. I'm going to show you a rendition of this method, okay, where you only use one mountain. Take the smaller factor, so 28, or smaller number I should say, 28, 1 times 28, 2 goes in because it's even, 2 times 14, 3 does not go in, 4 does not go in because it's, 4 times, 7, I meant to say 5 does not go in, 6 does not go in because 2 and 3 are not up there, 7 does, and I'm on the other side. Then you pull out your calculator, you do 45 divided by 28. If you get a decimal, it's not the GCF. 45 divided by 14, nope. 45 divided by 7, nope. 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 When your GCF is 1, that means it's already in simplest form. So if you use one mountain, you can just go ahead and divide. Go ahead and try the You Try section, and we will return to the lesson in a moment. Welcome back. Alright, we're going to try a couple of these. A couple of them we're just going to give you the answers. 15 over 45. I'm going to use the full mountain method. 1 times 15. 2 doesn't go in because it's not even. 3 does because 1 plus 5 is 6, which I can divide by 3. 3 times 5 is 15. 4 does not go in because it's not even. 1 in 45. Remember, use those divisibility rules to figure out what factors fit and what don't. It's not even, so 2 cannot go in. 4 plus 5 is 9. I can divide 9 by 3, so 3 goes in. 3 times 15. You need to double check how to get that 15. 45 divided by 3 is 15. Those fact families, they come in groups of 3. Horde is not going because it's not even. It ends in a 5, so 5 has to. 5 times 9 is 45. 6, it has to have a 3 and 2 in the list. It does not. 7. Now, 7s, it's a very special rule, so look back. No, let's not go back. Just look back. Your divisibility rule will just say it does not. There's a list of divisibility rules for 7. 8, 2 and 4 have to be in the list. It's not. 9 is on the list already. It's on the other side, so I'm done. Find the biggest number that they have in common, going right to left. I see 15 on both sides, so I divide top by 15. I get 1, because 15 divided by 15 is 1. 45 divided by 15 is 3. The answer is 1/3. Problems like number 2. One quick way to start it off. If you see a 0, cancel it out. 0 for 0, an I for an I. So I'm left with 3/5. Well, I know that 3 and 5, the only number that goes into both of them is 1, so I'm done. All right. Next one, I'll just give you the answers. We should have 5 over 27 and 7 halves. Now, those of you that, well, I shouldn't say those of you, all of you should remember that this is an improper fraction, which can be turned into a mixed number. 2 goes into 7 3 whole times, because 3 times 2 is 6, which leaves me 1 left over. 3 and 7. I only teach this last method because students use it no matter what. The guess and check method. I hate it. Don't use it. You will make mistakes. The only true way to get a problem correct 100% is to find the factors, find the GCF, and then divide. That way you are proving to yourself that there is a GCF and what the GCF is. So if you guess, that's the problem. A lot of students just say, oh, I've divided by 3, I am now done. If you guess, you must check. Use your divisibility rules. So let's look at these. I usually like to go in order. 2, 3, 4, etc. They're both even, so I'm going to divide by 2. That gives me 18. 162 is 81. And a lot of people just stop right there and say, oh, I'm done. I did something. I did some work, so I must be done doing the entire problem. Keep going. Okay, well, they're no longer both even. Maybe 3 works. 1 plus 8 is 9. 8 plus 1 is 9. That means it's divisible by 3 on top and bottom. Remember, if you add the digits and they're both divisible by 3, you can divide out a 3. 18 divided by 3 is 6. 81 divided by 3 is 27. Oh, I've done enough work. I'm probably done. Again, if you guess, you must check. 6 and 27. Well, I know 6 is even, 27 is not. 6, I know 3 can come out of it because 6 is divisible by 3. 2 plus 7 is 9, which means it's divisible by 3 again. 6 divided by 3 is 2. 27 divided by 3 is 9. I guessed. Now I need to check. 2, 9. Not both even. 2 is not divisible by 3. 9 is not divisible by 3. 4 won't work. 5 won't work. 6 won't work. 7 won't work. You need to make sure you check every possibility. The problem with the guess and check method is it oftentimes ends up leading to more work than you need to show. Okay? If you use either the single mountain or the double mountain method, you can find those answers a lot quicker and with a lot more efficiency and accuracy. There's an exit slip on this page. Give it a shot. I'll check it at the end of the week. Your homework. Just simplify these fractions to the lowest terms. Show all of your work. Show the mountain method. Show how you got this answer. If you're giving the guess and check method, show each and every guess and check. All right. Thanks for stopping by, guys, and I will see you in class.